Okay, very last one for this group. So we're looking again at secant. So the emphasis is going to be on the actual secant portion when it comes to the reciprocal, right? So we are looking at same stuff, right? Amplitude is 2, no reflection this time. So just 2, no need to worry about flipping it. We do have the period. Remember, the period is only affected by the number in front of x. Default period for secant is 2 pi, just like cosine. Divided by that 2 tells us the period is just pi, right? So it's been sped up. It moves through the entire cycle a little faster. We also have a phase shift happening here. I think I used orange for phase shift in the past. So when it comes to these, again, there's a couple of ways that you can kind of approach it. I'm going to treat it as a phase shift for cosine, which does not have any vertical asymptotes, so we'll kind of adjust as we go. So again, another way that you can kind of approach this, this one in particular, you have to be a little careful with because there's a pi, but there's also a 2 here. When it comes to the phase shift, those two things work together. So we can write it as negative b, let me write phase shift over, negative c over b. So we have our phase shift is going to be negative c over b. And what that means is I take negative of negative pi. Now, some people look at that and they only acknowledge the pi. They don't acknowledge the negative. If that's the case, then you make that positive, right? You basically are taking the opposite sign of whatever's there. Over 2, so your phase shift is actually pi over 2. Because it's positive, it's to the right. Another way we did this when we were dealing with cosine is we just set it equal to that first x value, right? So we box this so we've got it. Or you can just say 2x minus pi equal to 0 because that's the first of our key points. And in fact, let me just bring that chart in while we're talking about it. Okay, and we're looking at this first point right here of 0. So anyway, if you solve this, you'll move pi to the other side, and you get 2x is pi, divide by 2, which tells you x is pi over 2, again, being positive, means we send it to the right. So whichever of those processes makes more sense to you, I'm actually okay with. It's just that idea of you always want to be able to back up or to justify whatever it is you're writing down, right? So whichever option you go with, just make sure you have work supporting what you're doing. Okay, so as we look at that, then that means these are all going to change. We're only going a distance of pi. If we go with that gap, we're looking at pi cut in fourths, so just pi over 4. So each of these is going to be found by saying plus pi over 4, right? So we're going to start not at 0 because there's a phase shift. We're going to move that pi over 2 units to the right. So pi over 2, and then we're looking at 2 times this one right here. So pi over 2, 2. The x-intercept, that value, so again, I'm going to work off the pi over 2 that we just had, so pi over 2 plus the gap, which is pi over 4, and then 2 times 0. A half plus a quarter is 3/4, so 3 pi over 4, 2, right? 0, doing that. And then again, keep adding, so 3 pi over 4 plus pi over 4, 2 times negative 1 gives you 4 pi over 4, which I can write up here, 4 pi over 4, which is just equal to pi, so pi negative 2. We've got, again, we're going to add again, and I'm going to go back to the improper fraction form, so 4 pi over 4 equal to pi plus pi over 4, and this is 2 times 0, so it gives us 5 pi over 4, and then 0. And then this gives us 5 pi over 4 plus pi over 4, 2 times 1. So 6 pi over 4, and let me actually just write that off to the side, equals 6 pi over 4, which is 3 pi over 2. So let's use that for our answer. 3 pi over 2 and 2. Okay, so we're going to graph this. Again, I'm kind of focusing on cosine initially, and then we'll balance it out for secant. I'm going to leave myself a little room on the negative side. If you remember, you can even use our last example. The vertical asymptotes are a little bit, they kind of cut us right down the middle when we use our regular points. So I'm going to leave myself a bit of room to finish off my picture. This is a maximum, which means it's going to be a local minimum for cosecant, or for secant, excuse me. This is an x-intercept, which means it's a vertical asymptote at x is 3 pi over 4. It's a pi. This is a minimum, so it's going to be a local maximum. This is going to be a vertical asymptote at x is 5 pi over 4. And then this is going to be a local minimum. So let's graph these values. We're going up and down 2. So 1, 2, 1, 2. We're starting at pi over 2. And then we're looking at 3 pi over 4. And then we're looking at pi, 5 pi over 4, 3 pi over 2. X has to look like an X and Y. Okay, so as we look at these, we do have a local minimum, right? So if we plot this, we've got a point here, and we realize it's going to arch up, which I will sketch in formally in a minute. Okay, and then we've got a vertical asymptote or an intercept, so that they kind of double depending on the graph we're talking about. If we're talking about cosine or secant. This goes down here, and then another vertical asymptote, and then this goes back up. And hopefully you can look at that and you can see the graph of cosine. But hopefully you can see that graph of cosine. And then that would also mean, because we move in pi over 4 increments, we would actually have a vertical asymptote right here at pi over 4, which I didn't space very well. Let's call that Y, B, A. That would be at pi over 4 if you choose to sketch it in. So my spacing is off because I didn't plan for it maybe as well as I should have. But this gives you up here, right? There's your local minimum. There's a local maximum. And then continuing the graph. So we would include, there's a point, this is our end one. So 1, 2, 3, 4. So this one would come back down, and then we would go down here, back up, and we would end up here. So asymptote here. And then if we continued sketching this in, okay, and this would give us up here. Careful not to cross your asymptotes, right? Try to make it look like your graph stays within it. And then this one would really only be a half. Because I kind of backtracked and I added to the left side over here, I don't absolutely need to sketch this last piece in because I do have 2 full cycles without it, but it doesn't hurt. All right,